But I think the last due date was 16th.
Question 16. Okay. We have discussed the question 16. It was okay. All right. So now let us see question 17. Can you see the question 17? It's NEET 2013 question. So please read question 17. Then tell me how we can solve this. Give some clue so that we will proceed. Question number 17. Are you reading it? Question number 17. Have you read the question? Yashika?
Yes, sir.
So any clue how to solve this question? Do you know what is the dipole? I think you understand what is the dipole, right?
Yes, sir.
So what do you understand from this question? It says an electric dipole of dipole moment P is aligned parallel to a uniform electric field E. The energy required to rotate the dipole by 90 degrees. So now I'm moving to the board. So what is the question for? An electric dipole of dipole moment P is aligned parallel to uniform electric. So first we will understand what this question is saying. Suppose we have electric field E like this. So the question says an electric dipole moment P is aligned parallel to a uniform electric field E. So this dipole, suppose there is a dipole like this, dipole moment P. So this dipole is parallel to the electric field. Now what it says? It says the energy required to rotate the dipole by 90 degrees. So if we rotate the dipole by 90 degrees, suppose the new position of the dipole is like this. So now the position of the dipole becomes like this. Have you understood the situation? What have been asked in the question?
Yes.
Are you getting? So can you give me some clue how to proceed? How to solve it? We have been asked about the work done in rotating the dipole from parallel to 90 degrees. This dipole is rotated like this. Initially it was like this, then it's rotated, come to this position. So position 1 and now it is position 2. Any idea? Have you heard about potential energy of a dipole?
No, sir.
What is potential energy of a dipole? If a dipole, suppose we have electric field E and a dipole is like this, making an angle theta with the electric field. And suppose the dipole node of the dipole is P. You may have read the formula of potential energy. What was that? If a dipole is at angle theta with an electric field E, you may have heard like this: the potential energy of a dipole is minus P dot T. I think you remember this formula. Potential energy of a dipole is minus P dot T. Do you know this formula?
Yes, sir.
So actually what happens is we know all the formulas, but by practice we know how to use those formulas, right? Have you got assignments? I have given some assignments. Have you got that?
Not yet, sir.
So the formula for potential energy is minus P dot T. So you can put it like this: minus PV cos minus P cos. Now what happens is, we all know from class 11 that work done is always equal to change in potential. Is it so? Work done is always equal to change in potential. Same as gravitation. You may have studied gravitation. When an object is moving from one height to another height, then change in gravitational potential is equal to work. So you always remember that work done is always equal to change in potential. So here what will be the work done? Change in potential energy. It means potential energy in position 2 minus potential energy in position 1. Are you getting my point till now?
Yes, sir.
So what is the potential energy in position 2? Minus PE cos theta 2, angle in position 2, then minus of minus PE cos theta 1. Is it right? So delta W will be equal to minus PE cos theta 2 minus minus, it will be plus PE cos theta 1. Have you got till now? Now you can take PE common. So it will be cos theta 1 minus cos theta 2. Now we have to decide what is theta 1 and theta. What is the value of theta 1?
0 degree.
Correct. Theta 1 will be 0. Theta 1 will be 0. And what will be the value of theta 2?
90.
Yes, theta 2 will be 90 degree. So the dipole becomes perpendicular to it. So straightforward, you have to put the values here. So you will get P cos 0 degree minus cos 90. What is the value of cos 0?
1,
1. And what is the value of cos 90?
0.
0. So the value would be P into. So now check your option. What is P into? Option C is the correct answer. C is the correct option. The correct answer is C. Have you got this? Was it easy or tough?
Sir, it was easy.
So, we already know the formula U is equal to minus P dot E, but because of lack of practice or things, we don't understand how to apply the concept in a given question. And that comes step by step from practice. Practice, when you practice more and more, you will have idea how to apply the form. So, any doubt till now in this question? Should we move ahead?
No, sir.
Uh, So, moving to the next question. What next question is this? This is also same kind of question. So, you go through this question and give me some idea how to solve it. It's NEET for 2012. You're preparing for NEET, right?
No, sir, JEE.
For JEE, NEET and JEE, both or for JEE only?
No, sir, only for JEE.
So, first I will solve NEET question, then I will move to JEE. Since in JEE main most of the questions are asked same pattern of NEET, right?
Sir.
So go through the question number 18. The question says an electric dipole of moment P is placed in an electric field of intensity E. The dipole acquires a position such that the axis of the dipole makes an angle theta with the direction of the field. Okay. Assume that the potential energy of the dipole to be zero when theta equal to 90 degrees. The torque and potential energy of the dipole will be respective. So the language of the question is kind of bit illustrative or elaborative, but the question is very easy, which even you cannot imagine how easy is this question. You only have to write formula. The question says the dipole is making angle theta with the direction of the electric. Then the expression for torque and potential energy. You have only been asked the formula. So let us look how we can solve this question. The question is saying that suppose the direction of electric field is like this, and the dipole is this. So the dipole is making angle theta, electric field is like this, dipole moment is like this. So what is the torque and potential? We know what is the formula for torque. Can you dictate the formula of torque?
PE sin theta.
Correct. Mod of torque is actually in vector form it is P cross E, and we write in magnitude at P sin. So the value of torque is P sin. And formula for potential energy we already studied in the previous question, minus P dot. So the formula for potential energy U is minus P dot T, which is minus P. So now you see the options. Torque should be P sin theta and potential energy should be minus P. And if you see the option, which option is correct?
A.
A, obviously. So see how how the level of the question, how easy is this question. It's only, want to trap the student in the language of, like it gives when theta is equal to 90 degree, take potential energy 0. So that condition, when theta is 90 degree, potential energy is 0, is already considered in the formula. When we write the potential energy formula, this one, we already assume at theta is equal to 90 degree, potential energy is 0. We have already considered this. So there is nothing to be extra or nothing to be included from that statement. Straightforward we can use it. Got it? Any doubt?
No, sir.
Okay. Now move to question number 19. This question is little difficult or level 2 question. And such type of question is also asked in JEE. So go through question 19. Have you gone through the question?
Yes, sir.
The question says, question number 19, the electric potential at a point XYZ, all in meters in space is given by V equal to 4x square volt. The electric field at the point 102 in volt per meter. So in a certain space, the electric potential is given and we have to find electric field. That's all. So potential is given, we have to find electric field. Nothing more than that. So simply, what is the potential given? V equal to 4x square. So write it. The potential is given as V equal to 4x. In a certain region, the potential is given as V is equal to 4x square. Now it says find electric field at the point 102. So we have to find electric field at a point. Suppose there is a point P. 102 is the coordinate of that point. So we have to find electric field. Right? Got the question?
Yes, sir.
Okay. So can you give some clue how to solve this question? Anything comes in your mind? Okay, let me remind you formula. Do you remember a relation, a formula which have relation between electric field and potential? Since let us see, since how to decide which formula, I will give you some kind of you know thing how to decide which formula to use. Here you see, you have given the potential, right? And you have to find the electric field. It means you must apply a formula which should relate between electric field and potential. So what is that formula? Now go to that formula, remind that formula. Which was that formula which relate electric field and potential? So if you recall, you may remember you have read the formula E is equal to minus dV by dr. Have you remembered this formula? You may have seen this formula E is equal to minus dV by dr.
Yes, sir.
Correct. So this relation, this formula is the relation between electric field and potential. What exactly we are looking for? So in this case, what is the twist is here in place of R, what you have to write? dV by dx, since here the function of potential is in x. V is given in x. If it is given in y, we can write dV by dy. If V is given is a function of R, you have to write dV by dr. So here the function of potential is x. It is given as a function of x square. So we have to write the formula dV by dx. Got it? Got my point? So now our work has been reduced now. So we have to put the formula for V, which is 4x square. Now can you differentiate it?
Yes, sir.
Tell me what will be the differentiation?
Minus 8x.
Yeah, d by dx square, x square. So it's minus 4. What is d by dx plus x square?
2x.
2x, correct. So it comes as minus 8x. Correct. No. So the electric field is minus 8x. Now you have to find electric field at this point.
Minus 8.
Correct. Now you have to find electric field at the point 102, right? So what happens here is you will get E is equal to minus 8 into what is the value of X here in this coordinate?
1.
1, correct. So you will get minus 8 volt per meter. Got my point? So electric field should be along negative X direction and its value is 8 volt per meter. Now come to the options. See what are the options which matches with your answer. See the options. It says 8 along positive x-axis, 16 along negative x-axis, 16 along positive x-axis. What is the last option? 8 along negative x-axis.
So D.
Yes, correct. D is the correct answer. Have you understood?
Yes, sir.
So, was it tough?
No, sir.
So, the thing is how to apply the formula. The thing comes there. Okay. Now read the question number 20. Read the question number 20. Have you written this one in your notes? This solution?
Yes, sir.
Read question number. The question says the electric field at a distance 3r by 2 from the center of a charge conducting a spherical shell of radius r is capital E. Okay. The electric field at a distance r by 2 from the center. So the question says that electric field at a distance 3r by 2 from the center of the shell is capital E. Then electric field at distance r by 2 from the center. You have to find that. So let us understand it through a diagram. What question is saying? The question is saying that suppose I have a spherical shell and it is saying that at a distance 3r by 2 from the center. So this distance is 3r by 2 from the center. Electric field is E. Now you have to find electric field at a distance r by 2. Suppose this distance is r by 2. This is center suppose. So you have to find electric field at point P. Understood the question?
Yes, sir.
This is the shell. So can you solve it? What will be its value?
0.
Correct. It should be 0. Since at r by 2, the point is inside the shell. I have explained earlier also such kind of thing. If point is inside the shell, electric field inside a conducting shell is always 0. The correct option is B. Have you got this?
Yes, sir.
Okay. Now let us now let us do some JEE question. Then we will move to next topic. Some questions are also. Question number 25 is very easy. Only if you see the question number 25, you can easily solve it, right? Torque is equal to P cross E. Directly the formula is, you have to find the formula for torque. See question number 25. Very easy, right? Torque is equal to P cross E.
Yes, sir.
Then now we can see question number 23. This one is kind of JEE question. So you can go to question number 23. Read this question. Go through question number 23. 3-point charges. 3-point charges plus Q, minus Q, and plus Q are placed at the points 0, A, and Z equal to 0. Coordinates of the points are given. Then you have to find the magnitude and direction of the electric dipole moment vector of this charge assembly. So let us first understand the question. To find any difficulty in hearing voice now? Voice is clear, no?
Yes, sir.
Actually, earlier I was using mobile data. Now I have connected to Wi-Fi from today. Just I want to check that voice or everything is okay, right? Connection. So now let us see.
Sir, is it A?
Sorry,
Is it option A?
I didn't understand what you're saying.
Sir, is it option A the answer?
Oh, you're saying the option. I don't know. First, I have to see. Let us see. Oh, you solved so quickly, right? So let me check. So it says 3-point charges plus Q and minus Q. Let me check. Yes, you are correct. Its answer is A. You were telling A, right?
Yes, sir.
Have you understood the question?
Yes, sir.
So do you want me to solve this question? Okay, let me check what was your method. Maybe you can understand new method of kind of thing. So let us see what is this question says. 3 point charges plus Q minus Q are placed at 0, A and 0. So first see. So let us first draw the axis. Suppose I have like this X, Y, and Z axis, and the charges are put at plus Q is at Y equal to A. So the plus Q charge is here. You see, the plus Q charge is at X is equal to 0, Y equal to A, Z equal to A. The plus Q charge is placed here. Here the plus Q charge is placed. Then minus Q charge is at the origin. Minus Q charge is here. It is at the origin. So minus Q charge is placed at the origin. And if you see plus Q charge is at X equal to A. Plus Q charge is again at X equal to A. So there is one more charge plus Q charge which is at X equal to A. Suppose here. Got it? You understood the locations of the point?
Yes, sir.
Now let us see how dipoles are. So we know that dipole is always formed from negative to positive. So one dipole will be like this here, and one dipole will be like this. There are two dipoles here. Got it? So,
Yes, sir.
so for dipole 1, suppose dipole moment is P1 like this, and for dipole 2, dipole moment P2 is like this. So both the dipoles are perpendicular to each other, right? So
Yes, sir.
if two vectors are perpendicular, the resultant vector is P is equal to P1 square plus P2 square. And both are identical dipoles. So their dipole moment will be equal. Suppose it is P. So it will be P square plus P square. So its value will be root 2P. And what will be the value of P? Magnitude of dipole moment?
Q into 2A.
Q into 2A, but in place of A, 2A, here the separation is given as A, right? Here the separation between minus Q, here the separation between minus Q and plus Q is A. So in place of 2A, here what we will use? A. Actually the 2A was the separation between minus Q and plus Q charge, right? For convenience, we were taking that as 2A. But here, the separation between minus Q charge and plus Q charge is A, right? So here we will write A. Got it?
Yes, sir.
So it should be root 2 Q into A. So now check the option. It was A, right? Root 2 Q into A. Along the line joinings, or what will be its direction? Here we have many root 2K options, or three options showing root 2K, root 2K. But we have to see direction also. So the resultant field should be like this. The resultant field should be, yeah, it should be dipole moment will be in this direction, right?
Yes, sir.
So the option A is along the line joining point X origin and X equal to A, Y equal to A, correct? So this point, if we see this point will be x equal to 1, y equal to 1. Correct? This point will be x equal to 1 and y. And this is the order. So correct option is 3. Have you understood it completely?
Yes, sir.
Okay. So this was a good question. Such kind of questions are also good for JEE main. Such kind of questions are also asked in JEE. So now do some JEE question, then we will come again to the NEET question of basic practice. So let us open JEE. Some JEE questions. Till now, any doubt? Are you practicing yourself also? From where do you practice question? Let us see. Let me give you one more neat question, then I will find the book. The book is actually not visible here. So you will try one more question, then I will open the JEE book. You try the question number 33. Okay, question number 33. This is also neat question. Then I will open the JEE book. Can you see the question number 33?
Yes, sir.
You note it, or can you take kind of a screenshot or something? So that I will see. Have you taken the screenshot of this question 33?
Yes, sir.
You tried till now. I am searching through. Have you got that question?
Sir, 1 minute. I'm almost about to solve it. Sir, is it option B?
Option B. Let me check. Question number 33. You're saying B or D?
Sir, B.
It's D. Check once again. Have you got where are you? Where have you been wrong or something? Calculation state. Are you able to find out any mistake you have done or something?
No, sir.
Let me check. The question. The question says there is an electric field E in x direction to the work done on moving a charge of 0.2 coulomb through a distance of 2 meter along the line making angle of 60 degree with x axis is 4 joule. Then what is the value of E? So have you understood the question? First,
Yes, sir.
it says that there is an electric field E in the x direction and work done by moving a charge through a distance of 2 meter along a line making angle of 60 degree with x-axis is 4 joule, then what is the value of electric field? Okay, so let us check what it says. So there is an electric field in x direction. Suppose there is electric field like this. If the work done on moving a charge to a 2 meter along a line making an angle of 60 degree with it. So suppose we are moving along a line which is at an angle of 60 degree with the x-axis. Electric field is along x direction. It is x direction, and we are moving a charge 0.2 coulomb to 2 meter. So suppose I am moving a charge from point A to point B through a distance of 2 meter, then the work done is 4 joule. Work done in moving the charge from A to B, the value of charge is 0.2 coulomb. The value of charge is 0.2. So the charge is given as 0.2 coulomb, right? So you're moving a charge from A to B along the direction which is making an angle of 60 degree with the x-axis or electric field as shown in figure. So what concept you have applied?
So W is equal to minus Q integral of E into dx.
W is equal to minus Q integral E into dx. Okay. So what is the work done? We know that work done is always Q into change in potential. This we know, and also we know that E is equal to dV by dx, right?
Yes, sir.
So dV is equal to E dx. This means we know that dV is equal to E dx. Here we are only concerned with the magnitude, so we will omit the negative sign. There is no need to put negative sign. Now, here the problem is that you have to go to the actual formula. The relation dV is equal to E is equal to dV by dx is only valid when we are moving along the electric field. This formula of E is equal to dV by dr or dV by dx only valid when we are moving along the electric field, when angle is 0. But when you are moving at some angle with the electric field, in that case, the formula you have to use is E dot dx. Do you remember this formula? You may, when you were integrating, the formula for potential is like this, E dot dr. Do you remember?
Yes, sir.
So for general angle, we have to put dot. We remember the formula that we know one statement that electric field is always directed along maximum decrease in potential, right? So that in that case we apply the formula dV by dx. But when we are moving along some angle, we have to put the term cos theta, E dot dx. So now to calculate the work done, what we have to do? In this formula, delta W is equal to Q dV. In place of dV, we have to put E dot dx, right?
Yes, sir.
Now I think you will get the result. So let's find the work done. Delta W. So the work done delta W will be Q into E dot dx. Now see, what is the angle between E and dx? We are moving along. We are moving at an angle of 60 degree with the electric field, right? So
Yes,
it should be cos 60. So it should be E dx cos 60 degree. Or actually here the change in dx represent displacement, not change in x direction. Since we are not moving along x direction, you can also put it as r, right? Here we are not moving x direction, so you should not confuse. It is the displacement along x direction, right? You can directly write E into dr. So here we are not moving along x direction, we are moving along the line. So next, what is the value of q? 0.2 coulomb, right?
sir.
Value of q is 0.2 coulomb and x is 2 meter, right?
Yes, sir.
Dr is 2 meter. And what is the value of cos 60?
1 by root 2.
Cos 60 1 by root 2. Check your formula again. This is cos 60 1 by 2, right?
Yes, sir.
Cos 30 is, cos 45 is 1 by 2. So 2 and 2 cancel out. It should be 0.2 joule, right?
Yes, sir.
0.2 Newton per coulomb. Achha, in this case, the work done. Okay, let us come the distance 2 meter along line journey. Then what we have to find electric field here, right? We have to find electric field. So work done comes as 0.2 joule. There is a twist in there is an electric field in x direction. If the work done on moving the charge 2 coulomb to a long line making this, then find the value of, we have to find electric field value. So okay. Here we don't know the electric field, right? We also have to put electric field. This is not your final answer, since we have to find the electric field. So you also have to put the value E here. Since 0.2 is value of Q, right? And dr is value 2. Cos 60 is value half. So E remains here, right? E remains here. So it is E. And its value is given in the question. Delta W is given as 4 joule. Yes, in the question, delta W is given as 4 joule, right? It's 4 joule. So put the value, you will get, you should get. So 0.2 into E is equal to 4. So from here we will get E equal to 20. Okay. So this was our answer, right? 20. So D is the correct. Have you got it?
Yes, sir.
So we know the thing, but there is minor mistake, and sometimes forward to include those. Here the key point was dot here, the formula dot. Here if you see the key point was this. All the thing you know, we know. But this was the key point to apply this formula E dot PR, right?
Yes, sir.
Okay. Okay. Have you understood? So should we move ahead to a JEE question?
Yes, sir.
Okay. So let me play JEE. So some remaining question I will give you as assignment. Some remaining NEET questions. I have also given in the previous class. I have given some assignments. Let me check whether they have given. So you are going to write the JEE main exam uh, in when it is the JEE main exam?
Sir, I've just arrived in 12th.
When?
Sir, I've just started 12th.
It just started. So you are in class 12, right?
Yes, sir.
Okay, so you have enough time, you can practice. So both classes are going parallelly, right? I thought you have 12 pass. So you are just in 12, so you are studying 12th also, and side by side you are also preparing for JEE, right?
Yes, sir.
Okay, so you have enough time, and if you practice, you know, practice matters. You practice more, you will get more clarity of concept. And main is not much tough. Main easily you can crack. Little effort is required. I mean, some effort, not little, some effort is required for advance. If you have clear concept, you know the concept better, you have practice, you can crack the JEE main easily. And some up to advance. That is also if you have more practice, the advanced level question. These days, advanced is not also much tough. You should have the clarity of concept. You should have practice question you can do. You will see, you will do questions here also. You will see you can easily you can do the advanced question, main question. So you will get automatically you will get the confidence. So now let us see some electric topic one. This is topic one, electric charges and Coulomb's law, VSM JEE question. So let us see first question. 3 charges plus Q. You solve the question first. Try it. You can solve its JEE main 2019 question. You can easily solve it. So go through the question one. We have done such question in NEET also. Such type of question were asked in NEET also. Have you understood the question?
Yes, sir.
It says three charges plus q, small q and plus q are placed respectively at distance d by 2 and d from the on the x-axis. Then d by 2 and d from the. If the net force experienced by plus q placed at origin is 0, then value of q is. So the situation is three charges are placed respectively at distance d by 2 and d from the origin on the x-axis. If the net force expressed by plus q placed at one of the plus q charges placed at the origin and two charges of plus q are placed at d by 2 and d from the. So let us see, understand the question first. What question is saying? The question says that suppose I have like this. This is it. So according to the question, three charges. One of the charges placed at the origin. So suppose there is a charge plus q which is placed at the origin, and the other two charges are d by 2 and d. So there is one more charge, small q. Suppose this charge is small q. It is at d by 2, and then there is a charge plus q which is at d. So again the charge plus q. This is placed at d from d. So let me write it like this. So at the origin there is a charge plus q, and here also have charge plus q, and this charge q is at the bottom. Have you understood the question?
Yes, sir.
So the question says that the plus q at the origin force on the charge plus q at the origin is 0. It means force acting on this charge placed at the origin is 0. Got it? Force acting on this charge placed at the origin is 0. Then we have to find the value of small q. What is the value of small q? So first let us see how the force on the charge placed at the origin can be 0. If you see, for force on this plus q charge which is at the origin to be 0, if you see the electric field by this, electric field of this plus q will be towards left because it is a positive charge. So electric field here, or force, I can say force into plus q, charge will be towards left, right? Force on the charge placed at the origin here, and on this charge, force due to this charge must be towards left. because both the charges are positive. Have you got the direction of F capital Q? It should be towards left.
Yes, sir.
Now, to have force on this charge 0, force due to a small q must be towards right. Force due to small q must be towards right. Then it will be 0. It means force of a small q should be towards right.
Yes, sir.
When its force will be towards right, when this charge is negative. Got my point or not? For force on q to towards right, force on capital Q to be towards right, the charge on small q should be negative.
Yes, sir.
Now see the options. There are two negative options, minus q by 2 or minus q. So B and C are already omitted. If you see the options B and C, both are omitted, right? Now there is a fight between option A and B. Got my point?
Yes, sir.
B and C already omitted. So now let us see option. So here I can eliminate the option. B cannot be correct, C cannot be. Now we have to check for option A and option B. So for that, sometimes we already got result by option elimination method. If here there was not a negative sign, there was a negative sign only in one option, then without calculation we can say that this option is correct. But here we have negative sign in both A and D, so we have to solve. So for that, now we will find the forces due to individual charge. If we find the force due to small q, what will be its value? It will be A Q Q divided by D by 2 का whole square.
Yes, sir.
D by 2 का whole square. So it will be 4 A Q Q by D square. Now if you show the force due to capital Q, it will be K Q square by D square, right?
Yes, sir.
So what will be the magnitude? To balance the force, FQ should be equal to capital Q. To put the values, 4K Q Q upon D square should be equal to K Q square upon D square, right?
Yes, sir.
So from here, we will get 4K upon D square will be cancelled out. We will get Q equal to capital Q by 4. Obviously, it should be negative sign. Negative we have already decided. So the magnitude should be Q by 2. Now we check the option. If you're correct. Got my point? Negative sign we have already decided that the sign of Q should be negative. And the magnitude is Q by 2. Have you understood this one? This is
Yes.
JEE 2019. So this is how we decide. Okay.
Yes, sir.
So any doubt till now?
No, sir.
Okay. So I will, after the class, I will send you some assignments, also some NEET questions and some JEE questions. So you will try to solve those questions on your own, and Before starting the next class, we will discuss those questions. Okay.
Yes, sir.
So only 5 minutes is left, so we can do some short question or some statement kind of question. Same question is question number 8. This is same kind of charge, right? Question, right? It has been asked in 1986. Same kind of question which we have solved right now.
Yes, sir.
You may note this question or you can try it. I will give you in assignment question number 8. Now see question number 7. It says statement type of question. It says consider a neutral conducting sphere. Consider a neutral conducting sphere. A positive point charge is placed outside the sphere. The net charge on the sphere. This is based on the induction of charge.
Yes, sir.
The net charge on the sphere is negative and distributed uniformly. If you see, consider a neutral conducting positive point charge is placed outside the sphere. The net charge on the sphere.
Zero.
So option 1 says is then negative and distributed uniformly over the. Let us see what happens if we place a charge near a neutral conductor. So some charges are induced, right? There is always some induction of charge. Correct? I will not tell you the answer. I will explain. You will try yourself.
There is a zero.
What you are getting?
Zero.
The net charge on the sphere is then negative and distributed uniformly over the surface of the sphere. Negative and appear only at the point on the sphere close to the point charge. If I think you are right, it is asking about the net charge. So net charge will always be zero, obviously. Net charge should always be zero. There will be some kind of positive and negative charge, but if we ask about the net charge, it should be. So, okay. Any doubt till now? So we will end up here, and I will give you some assignments of NEET questions also and some JEE questions also, and we will discuss it in the next class. We could start the next class, and then we will do the new question. Right?
Yes, sir.
Okay. Okay, then we can log out.
Thank you, sir.